Hey viewers, welcome back to our channel. Hope you are doing extremely well. So today we are going to discuss another interesting question on the topic of binary tree, that is nothing but path sum in a binary tree. So before moving on to the question, if you guys are new to our YouTube channel, then please do consider subscribing our YouTube channel because we are making videos to educate the India. And if you guys are the regular visitor of our site, so let's move on to the question. So in this question that path sum in a binary tree, we are provided with a binary tree along with some value, that is the target value. And what we need to do in this question is that we need to find a path. Actually, we don't need to find a path. We either need to return the true or false. Okay, so let me make a tree and then we try to analyze what is the problem statement. Okay, because it will be easier if I draw a binary tree. So here it is 7, 3, 12, 1 and 0, and here it is 2. Similarly, here on the right hand side it is 9, minus 17 and minus 27, 10, and this is 13, 15 and 14. Okay, so I'm assuming the target value is nothing but 11. So what we need to do in this question is that we need to check that whether there any path exists from root to the leaf nodes whose value sum is nothing but 11. Okay, we need to check it. So how we'll check it? It is our problem statement. We will figure it out soon. So the first question that arises in my mind is that whether you get the problem statement or not. So let me explain it again. So what we need to do in this question is we need to check. We don't need to return. Okay, we don't need to find the values of those nodes. Okay, just we need to check, means either we need to return true or false. Okay, we need to check whether is there any path exists from root, means including this, to the leaf node, to any of the leaf nodes whose node value sum, means these each node have some value whose node value sum is nothing but equals to this target. Okay, now let's move on to the solution part. How will I solve this question? Okay, so just to solve this question, I will I will make a feed, or I will make a feed that each node will ask some question to its children nodes. Okay, each node will put up some question to its children node, and those children will return its answer either in true or false. So let's try to figure out what is the question that each node will ask from its children. So I just missed it out. Target was 11. Each node is going to ask a question to its children, that is the left children and the right children, that whether is there any path exist from you, means this 7 will ask from this 3 whether is there any path exist from you to the leaf node, to any of this leaf node where the node value sum is nothing but equals to some target value. What will be those target value? Target value will be nothing but 11 minus 7 will be 4. Okay, now you might be thinking that why I have decremented my target value with this value. So let me tell you what is the reason of it. Okay, so let me erase it at first. It is just because when 7 is asking a question from his children, when 7 is asking a question from the 3 and the 12, at that time 7 is actually including itself in the answer, and it is asking whether is there any path exists from you, means it is asking from its children whether is there any path exists from you to the any of the leaf node which will become a part of my answer. Okay, so what 7 is actually doing, 7 is actually including itself in the answer, and it is actually asking for the other positive candidates. Okay, so let me write here the 7. So 7 asking a question from the 3 whether is there any path exists including you, means from you to the leaf node. So we heard the target value where the node value sum will be nothing but 4. Okay, similarly the same question 3 will ask from its children. Here you can see here the node here there is no node. Okay, so this 3 will ask its question to from the left child. This 3 will ask a question from the left child whether is there any path exists from you to the leaf node where the node value sum will be nothing but 1 itself. Node value sum will become the 1 itself. Okay, similarly 1 will ask a question from its children that whether any path exists from you to the children where the node value sum will become 0 itself. Okay, So the moment this question get asked from the zero will say that yeah, I am the leaf node, and there is a path which where there is a path where the node value sum will be nothing but 0. Okay, because as it is a node value, as it is a leaf value, obviously there is no more nodes, so it includes itself in the answer and it's calculate the target sum, target value, actually target value, and here it comes to know that the target value is nothing but a 0. Okay, so as the target value is equal, so it returns true during backtracking. Similarly, as one gets the true, it returns true to the -3 during backtracking. Similarly, this -3 return true during the backtracking. So what we do, we usually make two recursive calls. 7 make two recursive call to its left and the right children by asking some question. What is the question? The question is nothing but, is there any path exists from you to the leaf node? Okay, highlight means make my words. I am asking question that whether is there any path exists from you to the leaf node. Why I am focusing to the leaf node? Just because it is asked in the question that we need to find a path from root to the leaf node, as root has included itself in the answer. That's why we are focusing each node, we are forcing each node to find a path till the root, till the leaf node only. Okay, means we don't want any path any of to the random node, we want it to the leaf node only. Okay, so I'm asking this question from this 3 1 0 2, and as we are using here the OR operator. Okay, so as I get an answer from the left side only, I don't need, it is not required to ask the same question from the right side only. So means these recursive calls are actually not required to make. So what I'm going to do is that now I'm going to write the code on the pap coding portal, and after writing the code we again try to analyze it. So let's move there. This is the pap coding portal. So let me increase the font size, and this is a function. Here is a function that is a has path sum function where we are going to write the code. So let's try to analyze, sorry, let's try to write the code. So let me at first so at first I will make a recursive call to the left function, has path sum, actually has path sum root dot not left dot, it is root left. Similarly, I will ask the same question from the has path sum from the right right child also, root right. Okay, now while asking the question, the value of the target get decremented by some value. Which value? It get decremented by a node value. We it get decremented by that node value which actually include itself in the answer. That means as root has included itself in the answer, so we need to decrement the target value with its value. That is root sum minus root value. Similarly, sum minus root value, sum minus root value. Now let me write some base cases. Okay, it is mandatory to handle the base cases, otherwise we get the null pointer exception. If our root reaches to the null, if root become the null, we will return false. Why am I returning false at the moment when root reaches to the null? Just because each time we are trying to find a path from root to the leaf node, and as the root reaches to the null, it means it has followed the path and it has already covered the path of the leaf node. And as we don't get answer at the leaf node, that means that path doesn't exist. Okay, so means in that case we need to return the false. Also what we need to do is that we need to check for the leaf node also, that if some value at the leaf node become equal to the target value or not. Okay, so if root dot root left equals to null, okay, null should be capital, I just forget it. Okay, I'm really very sorry. Null, root left null and root right null, root right null. And one more condition is whether the target value and the root leaf value sum is equals to or not. Okay, node value sum is equal or not. So sum minus root value, whether it is equals to 0 or not. If it is 0, I just return true in that case. True. Okay, so that's all for this code. Let's try to run it, and if it gets completely if it get accepted, we will take this code and we will try to analyze it on the whiteboard. So it is accepted. Let's try to submit it, and most probably it get accepted for all the test cases. Okay, so yeah, let me take the code for desktop, and let me take this code here, and let's try to analyze it. So this is the code. The first thing, okay, wait, let me erase something from here because it is too messy to work upon. So the first thing first is the our program execution start from the function name, and at first it encounters the root base case. Okay, so at first it checks whether the node value is root value or not. Okay, and the moment we come to know that it is not null, it is skip its part. Similarly, the next condition is of checking of the leaf node, and as we have just as we have just started iterating over the tree, we don't it is means that the node which we are accessing is definitely not a leaf node, so this part also get skipped out. Now it make a two recursive call, one to the left and one to the right, by asking the same question again and again. So at first it asks this question from the left node, and as the left node is also not null and it is not leaf, both of this part get ignored out, and again it make a recursive call by updating the target sum. Here the target value was nothing but 11, but here the target value was 4. Similarly, when another recursive call will made, the target value will become 1. Similarly, one will make a recursive call to this 0, and the target value will become 0. And this 0 is nothing but a leaf node, and as it is a leaf node and it is following the condition of sum minus root value equals to 0. Actually it was 0. It is actually cut it out from here. As it is following this condition also, it returns the true, and the moment this 7 returns the true during the backtracking, it returns true to the main function. It will not execute this part. While it will not execute this part just because we know that the OR condition works. Actually the OR condition work in a way, if one of the part return true, it will assume that other part will also be true, and even actually it ignores the second part. It will not even execute it. Okay, and after getting the true from the first part, just return that answer. I hope you get the solution of that video. If you like that video, please hit the like button, share it with your friends, and subscribe to our YouTube channel. Let's meet in the next video. Till then, stay safe, stay healthy.